Hello, welcome to the first episode of Math with Jay. So today we're going to be looking at this example of sigma notation. So how do you use this? This thing should help you get where the sequence starts. Where the sequence starts, it's called the sigma. So this helps you get to know where the sequence starts, and it starts at term number 1. If it's 2, if you find 2 here, it means your sequence is going to start at term number 2. So I'm going to help you know how to use this and this thing, and this is called a rule. This is going to help you get your sequence. This is going to help you get your sequence. You'll get to it, and then this is where the sequence ends. This is 100. It means your sequence ends at term number 100. This is the end. This is the end of sequence. So how are we going to start? So we're going to start by determining the frequency, this frequency sequence. So and determine what type of sequence it is. So we're going to substitute the start from the rule. So how are we going to do? So the start says your sequence starts at term number 1. So we're going to get the first term. First term, we're going to take this and substitute it to this. So it's going to be 4, 1 plus 5, of which is going to be 9. Then we're going to get the second term. Our second term is going to be 4, 2 plus 5, of which is going to be 13. So the third term is going to be 4, 3 plus 5, of which is going to be 17. Now we have the sequence. The first term is 9, the second term is 13, and the third term is 17. Now we have to determine whether what kind of sequence it is. So it's going to get the difference, of which the difference of T2 minus T1 is going to be 5, and T3 minus T2 is going to be 5. Therefore, you know what type of sequence it is. It's going to be the arithmetic sequence. So now, arithmetic sequence. Now there's another example of sigma notation question. So before we start answering question, we have 2 questions. We're going to analyze what we have been given before answering the question. So I see we have been given the start. So I call this a start. And what that means, we know where our terms start. So our sequence is going to start at term number 1. The P represents the term. So we've been also given the rule. So this is our rule, of which it's going to help us determine our sequence and what type of sequence it is, and this is where everything ends. So the last term of the equation, but we don't have it, so at some point we have to calculate it. But lucky for us, we've been given the value of terms that when they are added, they should not pass. So after adding a certain amount of values, a certain amount of terms, they should not pass 1000. This sign means the less sign. So that means the number of terms that are going to be added, the final answer should not pass 1000. So we're going to use all of that to determine it. But first we have to find our sequence. So we're going to need the rule to find our sequence. So, and we know that our sequence starts at 1. So we're going to find our first term. Our first term is going to be 1 over 8. 1 over 8. And we're going to substitute this 1 into this P. So it's going to be 1 minus 3. And this 1 represents the first term. So it's going to be 1 over 32. Check it. Please punch it in the calculator to confirm it for me. I'm doing it by head. So then our second term is going to be 1 over 8 times 2 to the power 2 for term number 2 minus 3 equals to 1 over 16, right? So now the third term is going to be 1 over 8 bracket 2, then 3 minus 3. 3 minus 3, of which is going to be 3 minus 3 is going to be 0. Any number to the power 0 equals to 1. Therefore 1 times 1 over 8 is going to be 1 over 8. So now we have our 3 terms, right? So we have 1 over 1 over 32. This is our first term. Our second term is 1 over 16. Then our third term is 1 over 8. Now we have to determine what type of sequence it is. So we have to have the common difference or the common ratio. If it's not, we're going to have a quadratic equation. But now it's going to start by minusing T2 and T1. And if the differences are the same with T3 minus T2, therefore it's going to be an arithmetic. So I just punched the calculator. The differences are not the same. So we're going to try dividing both T2 divided by T1 and T3 divided by T2. If the answers are the same, therefore we have a common ratio. Okay, the common ratio is 2. Therefore we have this is going to be our geometric sequence. So now we know that this is our geometric sequence. Now each sequence has a different summation formula. So first we have to find a summation formula for our geometric sequence. We have to find our geometric sequence. Now we know the sequence, and now we have to find the summation formula for geometric sequence, since the formulas for each sequence are not the same. So if I remember clearly, please check for me if it's correct. Our formula for geometric sequence is going to be Sn equals to A for first value, 1 minus r to the power n, close bracket, and this is all over 1 minus r. So our A is for our first term. Then our first term is going to us 1 over 2. So now, to understand okay, before I start substituting, let me explain this something. So when it comes to a summation here, the value you substitute here, you're supposed to be going to take our end and subtract it with our start, then add it with 1. So in this case, it's going to be n plus 1. It's n minus 1 plus 1, of which is going to be n. Therefore now our n is just going to be n. But let's say if here it was 2, therefore it's going to be n minus 2 plus 1. Therefore the final answer is going to be n plus minus 1. Therefore the value of n was going to be n minus 1. Let me explain why that is. So let's say we have 7 terms, right? Let's say we have 7 terms. 7 terms. 1, 2, 3, and 4. Well, let's say we have 4 terms. Then our start says we started 2, right? So now if I say we started 2, then I minus 2 at the end. It started 2. If I say we started 2, it means I'm going to say 2 minus 4. Since our end is 4 in this case, it's going to be 2 minus 4, of which of it's going to be this. It's going to cut here, of which is going, and we end up with 2 terms, of which is wrong. It says it starts at 2. That's why there's a plus 1 at the end. So therefore, if we say and okay, before we start with the substitution, let me explain something, how, because the value of this n, it's not going to be the same. So let's say we've been given something like this, our 4, and our p is equals to 2, right? Then our rule doesn't work. Let's say it's n plus 1, right? So for our n here, for the n we're going to substitute, let me make it a different color. Okay, sharp. So for the n we're going to substitute, it's not going to be 4 or 2, right? So we're going to say this is our end. We're going to say the end 4 minus this p, so which is 2, right? And plus 1, I'll explain the 1, of which is going to be 3, right? So let's say there are 4 terms, right? So term number 1, term number 2, term number 3, term number 3, I keep forgetting the 3. So term number 4. So it says we started term number 2, right? But we said 4 minus 2. If we say 4 minus 2, then the answer is 2, then we substitute 2. We're wrong, because if we say 4 minus 2, it's going to be 1, 2 terms, right? So it says it starts at term number 2, not after term number 2. So the plus 1, it's adding the term number 2, because it says we're starting here 1, 2, 3. So now if we say 4 minus 2, we're cutting out the previous 2 terms. So we're only left with 2, of which it's going to be wrong, because we're going to be end up adding 3 terms, which explains this one. If you don't understand, please comment. Now, so back to the original questions, substituting. So now, back to the original question. Okay, let me do this real quick. Right. So now, remember, in this case, we're calculating the n, right? We're calculating the n. So since we're calculating the n, it's Sn, right? So since we're calculating n, we know that it should not pass 1000. So we're going to solve for n. Since we're solving for n, we're going to take all these things should be under 1000, right? So it's going to be 1000 equals to a. Our first term it's 1 over 32. So it's 1 over 32. Then 1 minus r. What's our r? Our r is our ratio, and this is our ratio. Common ratio, it's 2. N, of which the term we're solving. Then minus 1 minus r, of which is our common ratio. So now we're solving for n, right? So now, to prove that thing, the n here, as Noah said, you're supposed to subtract, of which if it's term number 1, it's not going to change, because it's going to be, remember here it's 1. So since here it's 1, it's going to be n minus 1 plus 1, of which it's going to be n, right? So it won't change. But if it was 2, it was going to be n minus 2 plus 1, of which the final answer was going to be n. The final answer was going to be n minus 1, right? So now we know that our n won't change because it starts at term number 1. So now we have this. Now we have to solve for n, right? So we're going to use the algebra. This is basic algebra stuff. So we can start by dividing by 1 over 32. 1 over 32 to make it shorter. 1 over 32, of which this is going to be cancelling this. Then we're going to be punching the calculator for this term. Then the final answer, you can cross multiply it with these 2, right? Then we're going to use logarithms, of which it's our next topic. But for now, please solve that question. My challenge to you is to solve the rest. Then send me in the comments, or take the reply if you don't understand how to get to the final answer, and then we'll cover it on our next video. Thank you, and please subscribe and like the video.